set of eigenvalues of a 4 by 4 skew-symmetric orthogonal real matrix is. 4 set is given to us and we have to find which set is correct choice for the 4 by 4 skew-symmetric orthogonal matrix. As it is given to us, matrix is, suppose matrix A, I call it matrix A. Is it skew-symmetric? Skew-symmetric as well as orthogonal. Orthogonal, and we know there are some results about skew-symmetric matrix and orthogonal matrix. Every skew-symmetric, real skew-symmetric matrix has eigenvalue either 0 or purely imaginary. Purely imaginary, or in short, I can say this, if this is a real line and this is imaginary line, so eigenvalue of skew-symmetric matrix lies on imaginary line. Orthogonal matrix has eigenvalue unit modulus. Unit modulus. It means at a boundary of circle or circle circumference locus of all these points which normally we know circle. So these 2 points, this point and this point, are or will be eigenvalue of matrix A. It means for a skew-symmetric matrix, eigenvalue may be 0 or purely imaginary. In option A, there is no part of 0 eigenvalue or no 0 eigenvalue is here. So it may be possibility, because of purely imaginary part is given either positive iota or negative iota, and if we check its modulus, so 1 square root of 1 square is 1, and square root of minus 1 square or minus 1 square is 1 also. So both are true for this case, skew-symmetric orthogonal matrix. In option B, here eigenvalues are purely imaginary and as well as real number. So if it is skew-symmetric matrix, then plus 1 cannot be eigenvalue, either 0 or purely imaginary. But here this is saying plus 1 or minus 1. So this option discard by this rule. In option C, only positive or negative 1. It means it is not involving the case when eigenvalue may be purely imaginary. It's taking about for orthogonal matrix, not real skew-symmetric matrix. Because of real skew-symmetric matrix, eigenvalue may be either 0 or purely imaginary. So C is not a correct choice. Also, it will be either 0. It will be either 0 or purely imaginary, but same reasoning for as option B, as we discard option B by given number 1. Here eigenvalues are either 0 or purely imaginary. If we are taking eigenvalues purely imaginary or 0, then eigenvalue of 0 is not unit modulus. So option D discard by this. So correct choice with satisfying both skew-symmetric matrix and orthogonal, as well as option A is more accurate choice in these options.